Okay, for number 3, you're given two balloons at the same temperature and pressure. Alright, so it's same temperature and pressure. 14 grams of nitrogen and about 20 grams of argon. Now, if you think that nitrogen is about 28 grams per mole, alright, and argon is 40 grams per mole, that means I have a half a mole of each. So I've actually got 0.5 moles of nitrogen and 0.5 moles of argon. Now, since they're at the same temperature and pressure, that means they're also going to have the same volume. Okay, that's Avogadro's law, where if you're at the same temperature and pressure, the moles of one gas divided by the volume of that gas is equal to the moles of the other gas divided by the volume of that gas. So if we have the same moles for, say, 1 and 2, then we're going to have the same volume for 1 and 2. Okay, so we were asked to figure out which one of the following statements is false. So if you have the same volume, that means for nitrogen, you'd have 14 grams per volume, whatever that is, X, and for argon, you'd have 20 grams for that same volume. Alright, so they're going to have different densities, and statement A says they have different densities. One is less. That's a true statement. If you look at C, D, and E, on C, average kinetic energy is the same as the average kinetic energy of the argon molecules. Well, that's also true because they're at the same temperature. The volume is the same. We talked about that. If they're the same temperature and pressure, equal numbers of moles would have the same volume. So that's going to be true. And then it's a half a mole of each one, so it's half of Avogadro's number, so statement E is true. But if you look at B, the average speed of the nitrogen molecules, well, individually, like on the illustration we did in class, the speed is going to be different. The average kinetic energy is the same, but the lighter gas molecules, the nitrogens, are going to be going faster than the argons. So the answer would be B is false. Okay, for problem number 4, talking about which of the following items can be determined after the experiment. Well, that's the same as the lab. Alright, so I think you guys can figure that one out. Let's go on to number 5. Okay, for number 5, said the true volume is greater than ideal volume because of which of the following. Well, this is using the van der Waals equation. And you're not asked to actually plug anything in here, just figure out what's going on. We talked about the idea that the ideal gas law is not correct for the volume of the molecules. They actually do take up a certain amount of space, so the actual volume is greater than we predict, so we have to subtract out that factor.